Hi everyone. Today we will start a new chapter, System of Equations. Let's get started with 3.1, System of Linear Equations in 3 Variables. A system of linear equations refers to the presence of at least 2 linear equations which contain the same set of variables. The general form of a linear equation in 3 variables can be written as follows. ax plus by plus cz is equal to d, where x, y, and z are our variables, a, b, and c are constant that are not equal to 0. Let's compare the linear equation in 3 variables with the linear equation in 2 variables that we have learned before. The general form of linear equation in 2 variables can be written as ax plus by is equal to c, where x and y are the variables, a, b, c are constants. By comparing the general equations, all the variables are to the power of 1 because they are all linear, and the linear equation in 3 variables has an extra variables. When sketched on a plane, linear equation in 2 variables will form a straight line as shown in the diagram 1a. Whereas when linear equation in 3 variables are sketched, a 3-dimensional plane will be formed as shown in diagram 1b. There are 3 types of solutions to systems of linear equations in 3 variables. Either the system has one solution, infinite solutions, or no solution. For one solution, the planes intersect at one point only. Whereas for infinite solutions, the planes intersect along a straight line. When the planes do not intersect at any point, there will be no solution for the system. System of linear equations in 3 variables can be solved by finding the values of all variables so that they satisfy all 3 linear equations. There are 2 methods that can be chosen to solve for the values. They are elimination method and substitution method. The steps are similar to the method for solving simultaneous equation in 2 variables. We will try these 2 methods in the following examples. Let's look at the example 3.1.1. Solve the following system of linear equations using the elimination method. We are given 3 equations. The first one, 4x minus 2y plus 3z is equal to 1. We let it be equation 1. The second one, x plus 3y minus 4z is equal to negative 7. We let it be equation 2. And the third one, 3x plus y plus 2z is equal to 5. We let it be equation 3. This example specifically mentioned to use elimination method. Let's observe the equations. For the variable x, equation 1 has the coefficient 4, equation 2 has the coefficient 1, and equation 3 has coefficient 3. None of them are the same. The same go to variables y and z. Variable y has coefficient negative 2, 3, and 1 respectively, and the variable z has coefficient 3, negative 4, and 2 respectively. In order to use elimination method, we must make the coefficient of one of the variable the same. There are many combinations that you can choose to do. For this example, I choose to eliminate the variable x from equation 1 and 2. Therefore, I need to multiply the equation 2 by 4 in order to eliminate the variable x. Equation 2 times 4, we get 4x plus 12y minus 16z is equal to negative 28. We let it be equation 4. Keep in mind, equation 2 and equation 4 are the same equations. We proceed to eliminate the x. Equation 4 minus equation 1. 4x minus 4x is gone. 12y minus negative 2y minus 16z minus 3z is equal to negative 28 minus 1. We expand the bracket and simplify the equation at the same time. Negative and negative, we will get a positive. 12y plus 2y, we get 14y. Minus 16z minus 3z is minus 19z is equal to negative 28 minus 1, negative 29. We let it be equation 5. Equation 5 contains only two variables. We have used equation 1 and 2 to eliminate the variable x. Now we need to eliminate the variable x with other combinations of the equation. For the next combination, I choose to eliminate variable x from equation 2 and equation 3. In order to do so, I need to multiply equation 2 by 3 to make the coefficient the same. Equation 2 times 3, we get 3x plus 9y minus 12z is equal to negative 21. We let it be equation 6. Keep in mind, equation 2 and equation 6, they are the same. We proceed to eliminate the variable x. Equation 6 minus equation 3. 3x minus 3x is gone. 9y minus y minus 12z minus 2z is equal to negative 21 minus 5. We simplify the equation. 8y minus 14z is equal to negative 26. We can further simplify this equation by dividing 2. 4y minus 7z is equal to negative 13. We let it be equation 7. Now equation 5 and equation 7 contains only two variables, which is y and z. We continue to eliminate one more variables with equation 5 and 7. Both the variables y and z do not have the same coefficient for both equations. Hence, we have to do some alteration to eliminate either y or z. For this example, I choose to eliminate the variable y. Now our variable y have coefficient 14 and 4. In order to make the coefficients the same, we need to find the LCM for 14 and 4. We divide it by 2. There's no more common factor. Therefore, the LCM is equal to 2 times 7 times 2, which is 28. Hence, for 14, we need to times 2. For 4, we need to times 7. Equation 5, multiply with 2. 28y minus 38z is equal to negative 58. And this is our equation 8. Equation 7 times 7. 4 times 7, we get 28y. 7 times 7, we get negative 49z is equal to 13 times 7, we get negative 91. And this is our equation number 9. We eliminate the variable y by subtracting both equations. Equation 8 minus equation 9. 28y minus 28y is gone. negative 38z minus negative 49z is equal to negative 58 minus negative 91. We expand the bracket. Negative 38z, negative and negative, we get a positive. 49z is equal to negative 58. Negative and negative is positive, 91. We simplify the equation. 11z is equal to 33. We divide both sides by 11. Z is equal to 33 over 11, which is 3. Then we can substitute z equal to 3 into equation 5 or 7 to find our y. Substitute z equal to 3 into equation 7. 4y minus 7 times 3 is equal to negative 13. Expand the bracket. 4y minus 21 is equal to negative 13. 4y is equal to negative 13 plus 21, which is 8. Y is equal to 8 over 4, that is 2. To find our x, we substitute y equals to 2 and z equals to 3 into either equation 1, 2, or 3. So we substitute y equals to 2, z equals to 3 into equation 3. 3x plus 2 plus 2 times 3 is equal to 5. We expand the bracket and simplify it at the same time. 3x plus 2 times 3, we get 6. 6 plus 2 is 8, is equal to 5. 3x is equal to 5 minus 8, which is negative 3. X is equal to negative 3 divided by 3, we get negative 1. So this is how we solve system of linear equations in 3 variables using elimination method. First, we narrow down the system to 2 variables and then further narrow it down to 1 variables. Once we get the value for one variable, we substitute it into other equations to find out the values for the remaining variables.